You know, every time we step onto a plane, we're putting our trust in this invisible science. There's a whole hidden world of checks and balances, of unseen guardians, all working to make sure every single piece of that aircraft is ready to fly. So today, we're going to pull back the curtain on something called non-destructive testing, or NDT. It's the unsung hero that literally keeps our skies safe. All right, let's just get right into it. In most industries, there's some wiggle room for error. You can do a recall, you can replace a part. But in aviation, when you're flying tens of thousands of feet in the air, the margin for error is, well, it's zero. Failure is just not an option. And we've seen exactly why the stakes are just so incredibly high. Think back to 2010, when a Qantas A380 had that massive engine failure. Or 2018, when a fan blade broke off a Southwest engine, which so tragically led to a passenger's death. And just a few years ago, in 2021, that United flight started raining engine parts over neighborhoods in Colorado. All of these terrifying events point to the very same root cause: material failure. Now, here's the really mind-bending part. We're not talking about huge, obvious mistakes here. We're talking about tiny, almost invisible flaws. Little stress cracks, metal fatigue, things you could never spot with the naked eye. But those seemingly minor defects can lead to absolute catastrophe. So the billion-dollar question is, how on earth do you find a flaw you can't even see? Well, the answer lies in this brilliant field of science that was designed to solve this exact problem. It's called non-destructive testing. You'll hear it called NDT for short. And the secret is right there in the name, non-destructive. See, NDT is this whole family of techniques that lets inspectors look deep inside a part, check out its integrity, and find those hidden flaws, all without damaging it in any way. It's kind of like giving a jet engine a complete medical checkup, like an MRI or a CT scan. And this comparison right here really shows you why NDT is so elegant. With traditional destructive testing, you literally have to break a part to see how strong it is. Now that's great if you're developing new materials in a lab, but it's not so helpful for the actual turbine blade you want to put on a plane, right? NDT lets you test that exact blade, and then, when it passes, put it right into service. So when you boil it all down, NDT has two massive jobs. First, it's all about quality control during manufacturing, making sure every single part is perfect from day one. And second, it's about asset maintenance, which means inspecting those parts throughout their entire service life to catch any wear and tear before it even thinks about becoming a problem. Okay, so how does this magic actually work? I mean, how do you see inside solid metal? Well, let's open up the NDT toolkit and see how these different methods build a complete picture of a component's health. We're going to look at 3 of the most common methods, and they're all just different ways of seeing into a material where our own eyes can't possibly go. We're going to use sound, we're going to use X-rays, and yeah, even electromagnetism. So first up is ultrasonic testing. The easiest way to think about this is like sonar, but for materials. Technicians send these super high-frequency sound waves into a part, say a wing spar. If that sound bounces back in a weird way or way too early, that echo is a dead giveaway. It tells them there's a hidden defect deep inside, like a crack or some corrosion that's completely invisible from the outside. Next, we have radiographic testing. And this one's probably going to feel pretty familiar. It's exactly like a medical X-ray that shows you your bones. This method uses X-rays to create an image of a component's internal structure. It gives inspectors a literal picture of a part's inner health, revealing things like tiny voids or cracks inside a critical weld. And finally, there's electromagnetic testing. This method is an absolute rock star for conductive metals. And what's an airplane made of? A whole lot of aluminum. By creating an electromagnetic field right on the surface, inspectors can find incredibly small cracks around things like rivets and fasteners that you would just never, ever see. So, when you start putting all these different techniques together, you realize something really important. NDT isn't just a random collection of tools. It's the central hub of the entire aviation safety ecosystem. It connects everything from the moment a part is made on the factory floor to decades of service way up in the sky. Let's start at the very beginning, in manufacturing. Before a single component ever gets installed on an aircraft, it has to pass through this NDT safety hub. This is where quality is locked in before a plane ever even leaves the ground. And NDT is absolutely crucial here. We're talking about validating the raw materials before they're even shaped.
Then, inspecting components as they're being made, evaluating every single weld, giving engine parts and huge fuselage sections a final, incredibly rigorous inspection before they're cleared for service. Every single step is a safety checkpoint.
But the job isn't done when the plane rolls out of the factory, not even close. NDT continues to be that central safety hub for the aircraft's entire life, which can span decades of flights, turbulence, and just grueling conditions. What you've got to understand is that this is a continuous mission. On a very strict schedule, planes come in for heavy maintenance, and NDT technicians go on the hunt. They're looking for fatigue cracks, finding hidden corrosion, checking everything from landing gear under stress to individual turbine blades for the tiniest surface defects. They find problems before those problems even know they exist.
Now, all this incredible technology, it's amazing. But it's really only one part of the story. It's so easy to forget the human expertise that actually makes it all possible. Because behind every single scan, behind every inspection, there are highly skilled, highly certified people. These are the NDT technicians, the engineers, and the researchers who have to interpret all that data, make the critical calls on whether a part is safe or not. They are quite literally the guardians behind the Guardian technology. And for me, it's just this powerful reminder of how much we rely on systems we never even see. NDT is this invisible shield that ensures aviation safety. And it really makes you wonder, doesn't it? What other unseen guardians are out there, quietly working to protect our world every single day?